All of these processes have one thing in common. They are powered by energy, and that energy can be deadly. That's why it needs to be respected at all times. Whether you're clearing a jam or doing routine maintenance, you have to do it safely. That's where Lockout comes in. Lockout is how you respect and control the energy hazards of a machine or piece of equipment. The purpose of Lockout is to ensure that the machine or equipment is disabled and any energy still in the system is dissipated before anybody goes near it. This is known as a zero energy state. Every year, forestry workers are seriously injured or killed because machines or equipment are not properly locked out and de-energized. These lockout incidents don't have to happen. They can be prevented by simple and effective lockout procedures. In fact, companies have these kinds of lockout procedures in place. The law requires it. A typical lockout procedure involves making sure that any machine, piece of equipment, device, or power transmission line is shut down and safe to work with before you start any service, cleaning, troubleshooting, repair, or inspection. In most forestry workplaces, there are two main types of energy: kinetic and potential. Electrical energy is a form of kinetic energy, as in a saw in motion. Pneumatic and hydraulic components are examples of potential or retained energy. All types of energy have to be locked out. We have the technical know-how to ensure that machinery can be made safe before anyone approaches it. The main goal of this course is to show you how to recognize and follow proper lockout procedures. In this course, we will look at energy and energy control, recognizing and assessing danger zones, controlling energy hazards, and monitoring and enforcing lockout procedures. Now let's return to the classroom and begin by looking at what the law requires. Energy is all around us, in our personal lives and in our work lives. We come into contact with energy all of the time, without even thinking about it and without getting hurt. But the situation can quickly become hazardous if there is sufficient energy and it has not been properly controlled. Hazardous energy is any energy source that could cause injury or even death to a person. As we've learned, energy has the ability to do work, to make things move forward, backward, up or down, the ability to power something, to make it turn, spin, or rotate. There are two main types of energy in the forest industry: kinetic energy, which is the energy of movement, for example, a saw blade that's turning, and potential energy, which has the potential to do work and is usually stored in raised weight, pneumatic or hydraulic systems. How do we prevent an injury or even a death from exposure to a hazardous energy source? The answer to that question is simple. We lock out the source of energy so that no one can come into contact with it. The principle of the procedure of lockout is straightforward. Disconnect the machine or piece of equipment from the energy source. Then, make sure it is in a zero energy state by waiting for the energy, all of the energy, to dissipate before going into the danger zone. If lockout is done correctly, no one can turn the machine on while someone is in the danger zone. Lockout has two stages. The first stage is to isolate all sources of energy, such as the electrical power, so nobody can activate the energy until the work has been completed. The second stage is to neutralize all stored or potential energy sources, such as hydraulic or pneumatic components, or the energy stored in raised equipment. To illustrate the two stages of lockout, let's look at a machine commonly found in a sawmill. A resaw has three types of energy powering it: electrical, pneumatic, and hydraulic. In a proper lockout procedure, the electrical energy is no longer flowing to the resaw because the electricity has been cut off at the disconnect, locked out, and tagged. This is isolating the energy source. The disconnect has stopped the flow of kinetic energy in the form of electrical power to the resaw. The next stage in a lockout procedure is to neutralize any other energy sources. The pneumatic energy is bled off at the release valve. And the hydraulic energy for the feed rollers and the line bar is locked out and tagged at the electrical panel that runs the pump. This is neutralizing the energy sources, the pneumatic energy and the hydraulic. In this module, we learned about the two types of energy, kinetic and potential. Remember, lockout has two stages. First, isolate the kinetic energy source, and second, neutralize any potential energy source. In the next module, we will look at the danger zones around machines in a typical forestry workplace. The Occupational Health and Safety Act is based on the principle of the Internal Responsibility System, or IRS. Under this system, all workplace parties, including supervisors, managers, and workers, have a responsibility under law to make their workplace safe and keep it that way. One way to keep a workplace safe is to develop complete lockout procedures and to follow them every time without fail. The first two steps in developing a lockout procedure are recognizing and assessing danger zones. A danger zone is any area where energy hazards exist. Employees enter danger zones that require lockout for a variety of reasons. Machine operators might have to clear material flow problems such as jam-ups, pile-ups, misfeeds, or improper alignment of material. In some cases, operators may have to oil or grease equipment. Sometimes it's necessary to inspect or repair equipment, which can include inching or jogging. Very often, an activity like inching or jogging is dealt with by a mechanic or millwright. When a machine or piece of equipment needs to be worked on while live, a special written lockout procedure must be developed for that situation. The procedure must be machine-specific. This type of work on equipment can be done only by workers who are adequately trained and qualified and will use the specific procedure. The supervisor plays a key role, along with the Joint Health and Safety Committee, in the recognition of lockout danger zones, with the help of the most qualified employees. It's important that the employees who are responsible for recognizing energy hazards have the necessary experience and knowledge to do a thorough job. When the danger zones are being recognized, a thorough identification of all energy types must be carried out. The most common energy hazard in forestry arises as a result of mechanical motion. Any one of several types of energy or combination of energy can be used to drive machines, equipment, and processes. Electrical, pneumatic, and hydraulic are the most common examples of energy that create motion. There are three main types of mechanical motion. One is circular motion. The second one is an up and down motion. And the third type of mechanical motion is a back and forth. All three types of mechanical motion are potentially deadly hazards. Once all of the motion hazards have been identified, the next step in the recognition process is to identify the sources of energy for these hazards. A system that runs on more than one type of energy has more than one point of control. Electric pumps, for example, run hydraulic systems, which in turn run other parts of the machine or system. Again, remember, the ultimate goal of any lockout procedure is a zero energy state, where the machine or piece of equipment cannot be operated at all. There is no kinetic or potential energy left in the machine, making it neutral and immobile. After all the mechanical motion hazards and the energy sources have been recognized, the next step is to assess those hazards. To assess each hazard, the following questions need to be answered. 1. How serious could the loss be if the hazard is not controlled? This question looks at the severity of an incident, which could range from minor to significant to serious or even major. 2. How often is such a loss likely to occur if the hazard is not controlled? This question looks at the probability of occurrence, or how often it could happen. This could be classified as unlikely to happen, seldom happening, occasionally happening, likely to happen, or frequently happening. 3. To what degree does the control reduce or eliminate the hazard? This question looks at the effectiveness of the control. Will it eliminate the hazard or just reduce it? Keeping those 3 questions in mind, the overall risk of the hazard needs to be examined. Risk can be calculated by using the following formula. Risk equals exposure plus severity. Exposure refers to how often and how many workers are exposed to the specific hazards. Severity is the potential seriousness of the loss if the incident happens again. The loss could be a death, a critical, lost time or no lost time injury, or property damage. For example, if the possible consequence of an incident is death or critical injury, the severity is very high. But if the possible consequence is a sliver in the hand, the severity is low. If either exposure or severity is high, the risk rises. If both exposure and severity are high, the risk of injury to a worker is considered extreme. Supervisors need to do ongoing risk assessments of a lockout procedure by talking to workers, observing workers performing the lockout procedure, and making a note of any deficiencies in the procedure. Recognizing and assessing hazards are the first 2 steps in the 3-step process of developing a lockout procedure. Let's return to the classroom to look at the 3rd step, controlling energy hazards. The first 2 steps in developing a lockout procedure involve recognizing and assessing hazards. The 3rd and final step is controlling those hazards. A complete lockout procedure consists of several basic steps. First, turn the operating controls to the off position and lock them in that position if possible. Put the key in your pocket or in a lockout box. Secondly, turn the power supply off. Stand beside the box, not in front. Turn your face away and pull down the lever to shut off the power. There are different types of personal lockout devices that can be used to control hazardous energy. The best, most secure type is the single padlock with a single key. Scissors must be used whenever more than one person has to lock out at the same point. By using scissors, every worker can be sure that no one else can restart or test the machine while someone is in the danger zone. It's important to put a tag on the power supply so that other people know who locked out the piece of equipment or machine, the date of the lockout, and the reason for the lockout. After the power supply has been locked out, de-energize the system to deal with any other kinetic or potential energy that may still be present. This includes releasing pressure from hydraulic and pneumatic valves, inserting blanks, pins, or blocks, and waiting for any freewheeling parts to come to a stop. Depending on the machine or piece of equipment, you may have to return to the operator's panel, unlock the controls, and test every switch and every button to make absolutely sure that the power is truly off. Only after all power is off and all potential and kinetic energy has been dealt with is it safe to enter the danger zone. Even after the work has been done, the lockout procedure is only half completed. The same steps have to be applied in reverse before the machine can be returned to service. Guards that may have been removed in order to do the work need to be replaced. Tools or materials have to be picked up. Take out any blocking or pins that were used. After these steps have been completed, clear the danger zone and remove the lock or locks and tag from the electrical box. Turn the power on and return to the control panel to test and restart the machine. The lockout procedure for a computerized system, often referred to as a programmable logic controller or PLC, works on the same principles as we've just discussed. Following the right step-by-step procedure each and every time will ensure that there is no danger to the person in the danger zone. Using personal keyed padlocks with only one key will guarantee that the machine and the power are off and that no one can activate them. Once the lockout procedure has been written, it needs to be validated. Usually the operators, the Joint Health and Safety Committee, or Health and Safety Representative, along with the supervisor, electricians, and millwrights, will be involved in this validation. This and any other lockout procedure are only part of a lockout program. A lockout program must also ensure that the lockout procedures remain current and effective and protect workers on an ongoing basis. Once the lockout procedures have been validated, you need to be able to show that the procedures are valid. This involves verification of the program by keeping and maintaining a series of documents related to the lockout procedure. The important final step before putting the lockout procedure into practice is to train workers in the process. Properly validated lockout procedures, a properly verified lockout program, and proper training on the procedures go a long way to ensure the health and safety of workers. A regular, preferably annual, review of lockout procedures is an important element of any lockout program. A key to the success of any lockout program is monitoring and enforcement of the lockout procedure. Let's return to the classroom to examine that important responsibility.